Okay, so here we are. So I'm Jeremie Garnier. I will give you some details regarding implementing a DevOps pipeline based on microservice application using Docker. I'm working on the CTO office led by DevWorld. So basically, we'll just give you a quick update on what the context of Objective, and we'll go deeply the microservice architecture and about the continuous everything stuff, though, so from the integration to the deployment part. So we've built a framework in order to use the multi-screen experience and development for synchronized application. So we did not put any constraints on the application side, so it can be native application or HTML5.1. And we did implement a DevOps approach in order to deliver faster with still the highest quality as possible. And we are using Docker because this is really useful from the development side in order to easily get the end-to-end environment running everywhere. So basically, we are used to build monolithic layer application. But now we need to build microservice application in order to better manage the scalability and the flexibility of the application. And just to give you an overview, so here is the current architecture we've designed. So you will see that each blue box is a container, and then we've divided the application on several parts. You've got the database storage based on Mongo, the PubSub system using Redis, and we've got also a physics engine available as a separate entity, and we've got the layout engine core, which is based on Node.js, which will contain all the documentation parts up to date with the code and also the API available. And then we've got two separate models for the application. Why we use Docker and the registry that comes with is that it is really easy to package subparts of the whole solution. Then with only 2 minutes, I can get an end-to-end system running on my workstation. And it allows faster deployment because the first time you will get the whole image, but after you only get the delta that have been done on the container. And we use the registry just for pushing and pulling images. So the key thing is that we need to move fast and break no things. You know that Microservices talk about move fast and break things. But in our case, we need to move fast and break no things. That's why you need to have an automated pipeline from the development workflow. But you need to ensure that as it's automated, you need to put some checkpoints regarding tests and so on. So as you can see, for each commit, we are building a new Docker images. We've made unit tests, but we also make group tests on the Jenkins slave. So in order to ensure that the Docker image is clean, and so the registry will only contain stable Docker images. And after, once you deliver the Docker container to the registry, we will perform continuous deployment using SaltStack. First on the staging environment to run end-to-end tests, but also load tests. And if it's run fine, we are moving to the production environment. So each commit goes automatically from the workstation to the production environment. Just a few words regarding the Sandbox Mode. We did apply a Sandbox Mode in order to have a clean registry, as said. So for each commit, I will run the whole end-to-end system within the Jenkins slave before pushing to the registry. And the key part is always the test part. You need to apply continuous testing from the dev environment to the production. So that's why we put in place the sandbox environment with end-to-end tests to ensure that we do not break anything, but also load testing for detecting bottlenecks and ensuring global stability of the solution. So basically at the moment, everything is here to play with on the open source community. So as an example, you can use Frisbee, which is an open source framework for testing REST API. And basically I just put one example here. With one line of code, you can easily test one API. And now regarding the load test, you can also use Gatlin, which is a open source stress tool. And I also put one simple example with only 3 lines of code. You can perform load test. And you also have a good dashboard available. And this is also key in the DevOps approach to give a lot of visibility with a lot of dashboard to everyone in the system. And then also it is good. It's also important for developers to write documentation. It is always hard to maintain, but if you consider some open source framework that can use the code to generate automatically this documentation, you can use Swagger to easily have an up-to-date documentation linked to the code. And then it also provides a good API to play with in order to test your API. Now back on the final point is the continuous deployment. So we are using SaltStack because this is really a good solution to easily manage the deployment of your application. And so we are, in order to orchestrate all these tools, we designed just a little tool, which is a scheduler on top of SaltStack, Jenkins, and so on, which will make all the link. And then in this example, you can see that I can have a list of the Docker container available, and I can push them if I want to the staging environment or to the production environment, and automatically all the tests will rerun again. So last few words, so you saw that we've performed continuous integration, test, delivery, and deployment, and now we come to the ops world. So I said that this is a DevOps approach, but this is not a full DevOps approach, because once you are on the ops world, you need to continuous monitoring your application, you need to provide feedback, and you need to improve also the application. So we've just done half of the work, because we are now in the ops world, but we will work with the ops team because we give a lot of visibility about what is going on in the system, what is the update, when it is available, what to deploy, where it's deployed. And so that's it. Thank you.